So, at the beginning, we should know what is meant by absolute value. Absolute value refers to the distance of a number is from 0 and always positive. Those two vertical lines are called absolute value. If we draw a number line or an x-axis and I asked you how far a number 2 is from 0, we have both negative and positive sides. At the negative side, we have minus 2 is 2 away from 0, and at the positive side, 2 is 2 away from 0. We can say that this 2 on the negative side is the absolute value of minus 2 on the negative side. Also, this 2 on the positive side is the absolute value of 2 on the positive side. We can say that absolute value of minus 2 is equal to 2 and absolute value of 2 is equal to 2. So the absolute value of a real number is denoted by absolute A and is defined as absolute A is equal to A if A is greater than or equal to 0 and is equal to minus A if A is less than to 0. We have also properties for the absolute value in the form of e power n equal to A. Case 1. E power n equal to A, n is even, A is positive. It has two roots, e equal radical A index n or e equal minus radical A index n. Example, x to the power 4 is equal to 81. X equal plus or minus radical 81 to the index 4. 81 is the form of 3 to the power 4. So the solution set is considered as minus 3 and 3. In case 2, e to the power n equal to A, where n is even, A is negative. There is no solution in R, it's impossible. For example, x squared equal to minus 4. If x, its sign is negative, x squared equal to x times x. Where the sign of x is negative, we have negative times negative is equal to positive, which is not true, which is not equal to negative. So no solution in R and impossible. So the solution set contains phi or empty set. In case 3, e to the power n equal to A, where n is odd, A is positive or negative. It has one root, e equal radical A of index n. For example, x cube equal to 27, x equal radical 27 of index 3. 27 is the form of 3 power 3, x equal radical 3 power 3 to the index 3. The solution set contains 3. The nth root of A are solutions of equation x power n equal to A. The square roots of a positive number are solutions of equation x squared equal to A. For example, we have x plus 1 is a fourth root of 81. X plus 1 alone is a fourth root. Fourth root is power 4 of is equal to 81. So we have x plus 1 all to the power 4 equal to 81. It's the same as case 1. E power n equal to A, where n is even, A is positive. N is even, wherefore A is positive, where 81. So x plus 1 equal to radical 81 power 4, or x plus 1 equal to minus radical 81 to the power 4. 81 is the same as 3 power 4. Now to the intervals. There is many notations. The first one, closed interval, half closed interval, half open line, half closed line, open interval, etc. So in the interval, there is some important notes we should know. The first one, if we have unknown, the inequality must be bounded x greater than, x less than. While if there is positive infinity or negative infinity, there is only x greater than or less than, greater than or equal, less than or equal only. So if there is closed interval, it means or equal and a straight line on the representation of a number line. If we have open interval, means not or equal and a dotted line. Positive infinity, we draw an arrow to the right. Negative infinity, we draw a arrow to the left. How to read this system? X minus 1 greater than 4 and minus x plus 2 less than or equal to 1. Inequality 1, x minus 1 greater than 4, x greater than 4 plus 1, x greater than 5. From 5 till positive infinity. Opened at 5, opened at positive infinity. Open at 5 because there is no equal. Opened at positive infinity because the infinity is unlimited. Second inequality. Minus x plus 2 less than or equal to 1. Minus x less than or equal to 1 minus 2. Minus x less than or equal to minus 1. We have minus at x. We should have x only. So we multiply by a negative number. But if we multiply or divide an inequality by a negative number, we flip the inequality sign. So we get x greater than or equal to 1. From 1 till positive infinity as an interval, because there is or equal closed at 1, opened at positive infinity always and negative infinity always, because they are unlimited. Now, if we draw a number line, we have plus 5 till plus infinity, dotted at 5 and an arrow through positive infinity to the right. 1 till plus infinity, close at 1, open at positive infinity. A straight line at 1 and an arrow through positive infinity to the right. Now, where we have two coats of paint or two parallel lines from plus infinity till from plus 5 till plus infinity, both are open because plus 5 is dotted. Examples about absolute value. 1. Absolute 400 minus radical 1. Squaring both sides. 400 square is equal to 160,000. Radical 1 square is equal to 1. So 400 is greater than radical 1. So we leave it because 400 have a positive sign. 2. Absolute radical 2 minus 1. Radical 2 square is equal to 2. 1 square is equal to 10. To 1. Radical 2 is greater than 1. So we leave it because radical 2 have positive sign. Minus 3. Minus outside absolute 1 minus radical 2. We leave minus outside bracket minus 1 plus radical 2 because radical 2 square is equal to 2. 1 square is equal to 1 and radical 2 have a negative sign and greater than 1. So we multiply by a negative number minus bracket minus 1 plus radical 2. So we get 1 minus radical 2. 4. Absolute x minus y, where x less than y. If we take the y beside the x, we have x minus y less than 0. It is a negative. So we should multiply it by a negative sign. So we get minus x plus y. Absolute for a, where a is negative, less than 0. Let's put minus 1 inside a. Absolute 4 times bracket minus 1 absolute equal to minus 4 in the absolute. So we multiply minus by minus. So we have 4. Absolute for a is equal to minus for a because the minus outside times the minus inside a gives plus. So we have absolute for a equal to minus for a. Solving inequalities with absolute value. In case a greater than 0, absolute x equal to 2, two roots, x equal to 2 or x equal minus 2. Absolute x greater than 2 have also two roots, x greater than 2 or x less than minus 2. 3. Absolute x less than 2, bounded, should be bounded always if x greater than 0. So we put x in the middle, x greater than, x less than, minus 2 then 2. So we have minus 2 less than x less than 2. In case a less than 0, absolute x plus 3 equal to 1, absolute x equal minus 2. Absolute x is positive always, equal to minus 2 negative. Impossible, no solution in set R, so solution set contains phi. 2. Absolute x plus 8 less than minus 4, absolute x less than minus 4, absolute x positive less than negative, which is minus 4. So impossible, no solution set R. So solution set contains phi. Absolute x greater than minus 1, absolute x positive greater than negative, always true. So solution set contains set R. Absolute x less than or equal to 0. X equal to 0 since let's divide it into two parts. Absolute x less than or equal to 0. X less than 0 and x equal to 0. X less than 0, which is negative, impossible, but there is x equal to 0 positive, so true. So absolute x less than or equal to 0 is equal to x equal to 0. Absolute x less than 0, which is negative, so impossible. Solution set contains phi. Absolute x greater than 0, so x is not equal to 0. Absolute x greater than or equal to 0, always positive. So positive greater than positive, so always true. So let's solve some examples. Absolute x greater than or equal to 4. Like which rule looks like absolute x greater than a where a is positive. So absolute x greater than or equal to 4 have two roots. X greater than or equal to 4 or x less than or equal to minus 4. If we want to write it as interval, we have minus infinity till minus 4, closed at 4, opened at minus infinity, because x less than, which is minus infinity, or equal, so closed at minus 4. Union 4 till positive infinity, closed at 4, opened at positive infinity because it's unlimited, closed at 4 because there is or equal. 2 minus absolute x plus 2 greater than 0. 2 minus absolute x greater than minus 2 minus absolute x greater than minus 4 minus absolute x greater than minus 4 multiplied by minus 1. So if we multiply or divide an inequality by a negative number, we flip the inequality sign. So we get absolute x less than 4. So like which rule it looks like? Absolute x less than a where a is positive. So it's bounded between minus 4 and 4. 3. Absolute 6 minus 3x plus 6 less than 0. Absolute 6 minus 3x less than minus 6. So positive less than negative, impossible. So solution set contains phi. 4. Absolute x minus 4 minus 2 less than 0. Absolute x minus 4 less than 2. Like which rule it looks like? Absolute x less than a where a is positive. So it's bounded. So we put in the middle x minus 4 greater than or less than minus 2 and 2. Then we add 4 to the 3 sides. So we have minus 2 plus 4 less than x minus 4 plus 4 less than 2 plus 4. So we have 2 less than x less than 6. Another example, we have a system contains absolute x greater than 1 and absolute x less than 3. Then we solve each inequality alone. Inequality 1, absolute x greater than 1, it looks like absolute x greater than a where a is positive. Second inequality, absolute x less than which is 3. Absolute x less than a where a is positive. So the first one is not bounded, the second one is bounded. The first one, absolute x greater than 1, have two roots, x greater than 1 or x less than minus 1. The second one is bounded between minus 3 and 3. So if we want to write as interval, The first inequality, x greater than 1, greater than it means plus infinity. There is no or equal, so open interval at both sides. X less than minus 1, from minus infinity till minus 1, both are open because there is less than, which is minus infinity, and there is no or equal, so open interval. Between x greater than 1 and x less than minus 1, there is union. Inequality 2, from minus 3 till 3, both are open because there is no or equal. Test your knowledge. Solve the following, then draw them on a number line. A. Absolute x minus 1 greater than or equal to 4. It looks like absolute x greater than or equal to a, where a is positive. It has two roots, x minus 1 greater than or equal to 4, or x minus 1 less than or equal to minus 4. X greater than or equal to 4 plus 1, x greater than or equal to 5. On the other side, x less than or equal to minus 4 plus 1, x less than or equal to minus 3. If we want to write it as interval in order to draw a number line, so we have 5 till plus infinity, close at 5, opened at positive infinity. Because positive infinity because there is or greater than, and because there is or equal, so we have close interval at 5. Union, open interval from minus infinity till minus 3, closed at minus 3 because there is or equal. B, we have a system, so how to read it? X minus 1 greater than 2 and minus x plus 5 less than 3. X minus 1 greater than 2, x greater than 2 plus 1, x greater than 3. How to write it as interval? 3 till plus infinity, there is no or equal, so open interval. Minus x plus 5 less than 3, minus x less than 3 minus 5, minus x less than minus 2. So we should multiply by a negative number, which is minus 1. So if we multiply or divide an inequality by a negative number, we flip the inequality sign. So we have x greater than 2. From as interval, we should write it like this: from 2 till plus infinity, opened at both sides. C. Absolute x less than minus 0.8. It looks like absolute x less than a, where a is negative. Impossible, no solution in R, so solution set contains phi because absolute x is positive, less than negative. Impossible. Question 2. What is the intersection between A and B? A intersect B. We draw a dotted line from minus 5 till minus 1, and from 0 is a straight line till positive infinity. This is A. Now B. Under it, we draw a straight line from minus 3 till negative infinity, from minus 2 till 3, where 3 is dotted while minus 2 is a straight line. So, where we have two coats of paint or two horizontal parallel lines, from minus 5 till minus 3, opened at minus 5, closed at minus 3, and also we have 0 till 3, opened at 3, closed at 0. So A intersect B equal minus 5 minus 3, opened at minus 5, closed at minus 3, union 0 till 3, opened at 3, closed at 0. Question 3. Solve the following equations. A. X cube equal to 27. It looks like e power n equal to a, where n is odd and a is positive, so it has one root. X equal radical 27 to power 3. 27 is the form of 3 power 3. So we have x equal radical 3 power 3 of index 3. So x equal to 3. So solution set contains only 3. singleton 3. B. X minus 6 all to the power 2 equal to 9. It looks like e power n equal to a and is even, a is positive. X minus 6 equal radical 9 or x minus 6 equal minus radical 9. X minus 6 equal to 3. X minus 6 equal minus 3. X equal 3 plus 6. X equal to 9. X equal minus 3 plus 6. X equal to 3. So solution set contains 3 and 9. Which is perfect. C. X power 4 equal to minus 16. It looks like e power n equal to a where n is even, a is positive, a is negative, sorry. It's impossible because if the sign of x is negative, then we have x times x times x times x, minus times minus times minus times minus. Minus times minus gives plus, plus times minus gives minus, minus times minus gives a plus, so impossible. Solution set contains 5. D. X to the power 2 over 3 equal to radical 25 index 3. It looks like the form of radical e of index n equal to a or e of to the power 1 over n equal to a. We have radical x inside to the power square of index 3 equal radical 25 of index 3. So we have the same indices, so we should raise them to the power 3. X to the power 3, x square, equal to 25. It looks like e power n equal to a where n is even, a is positive. It has two roots, x equal plus or minus radical 25, x equal plus or minus 5. The cubic root of 27 is 3. The cubic root is power 3 of means equal, 27 is the answer. So we have 3 power 3, is it equal to 27? 3 times 3 times 3 equal, is it equal to 27? 27 equal to 27, so true. F. X minus 2 all to the power 3 equal minus 27. It looks like e power n equal to a where n is odd, a is negative. So it have one root. X minus 2 equal radical minus 27 index 3. X minus 2 equal radical minus 3 to the power 3 equal to 3 index 3. X minus 2 equal minus 3. X equal minus 1. Solution set contains singleton minus 1. G. X plus 1 is a sixth root of 64. X plus 1 alone is a sixth root, which means power 6. Of means equal, 64. Answer. X plus 1 all to the power 6 equal to 64. It looks like e power n equal to a where n is even, a is positive. It has two roots. X plus 1 equal radical 64 index 6 or x plus 1 equal minus radical 64 index 6. X plus 1 equal to 2, x equal 2 minus 1, x equal to 1. X plus 1 equal minus 2, x equal minus 2 minus 1, x equal minus 3. So solution set contains minus 3 and 1.